Assalamu alaikum all viewers and dear students. Today we are going to proceeding for the next MCQs on the same chapter number 3, vector, question number 56 for non-collinear vectors A and B. The correct formula is applicable for the non-collinear points, collinear vectors here. So these are the points are given. If we are apply the given condition, so here the answer, correct answer is according to the conditions. So correct answer is D. Because of that, M, N are any numbers and A and B are any three non-collinear points. Non-collinear points, they are not passing on the same line is called non-collinear points, and their same collinear points they are passing on the same line, so that is called collinear points. And here they are not passing on the same line, so their resultant will be equal to 0. And in case of p is equal to 0 and q is equal to 0, if we put p is equal here, p in the place of p, here we put m condition, all of them condition here. M is n, and here m and n both are equal to 0. If we replace here 0, and so we will get the result is 0a plus 0b, the result will be equal to 0. 0 is equal to 0. So, and this condition is satisfied when case of for the non-collinear point. So the correct answer is here is D. Of I minus j and j minus k and k minus j are what is according to the scalar triple product we have already discussed in the previous video. Scalar triple product, we know that the formula according to this rules, if we are expanding by this one, the coefficient of the first vector here is 1 and minus 1, 0, and here is iota is absent, j is the coefficient is 1 and k is minus 1. Similarly, here I is absent and k is equal to 1 and j is equal to minus 1. So expanding by first column, if we are expanding by first column, so what is the result? Expanding by first column, so what is the result here? 1 multiplied by 1 multiplied by 1 minus 1 into minus 1. So what is the result? 1 multiplied by 1 minus into plus minus 1. So the result will be equal to 0. So this will be 0. The correct option is in here is C is the correct option according to the scalar triple product. Vector addition is applied just in the law of commutative law are applicable in this case. Not defined, not associative, commutative, and anti-commutative. Anti-commutative are applied in A dot B dot product or cross product. So, and here vector addition so is just only applicable for the commutative law is the correct answer, because the vector addition is just like if we take any two vectors A and B or any two vectors, we can write this one B plus A vector. So this is the commutative law of J and C is equal to K, then A dot B cross scalar triple product is required. If directly we have applied here A dot B cross C is given that, so we can write B cross C according to this definition of cross product I and J and K. So here B cross C, here is A, B and C. B cross C. B cross C is given that B cross C. So we will get the answer is here A. And here A dot A we can write. So the result will be in the dot product A dot A is equal to B dot B and C dot C is equal to 1. Here the correct answer is C. B as the correct option is correct. In B it holds that A dot B, this is dot product A dot B is equal to A magnitude B magnitude cos theta if they are perpendicular to each other. This is the formula is given A dot B. A dot B is equal to A magnitude and B magnitude and cos theta. The condition is that here if A magnitude A is given that is equal to A square root is equal to A dot A. A dot A we can write for any A is given that A is equal to B. If both are equal here A and is equal to B. So we can write A is equal to B means that A dot A. So A dot A is equal to, and that means that they are parallel to each other. And this condition, so condition A is the correct answer when A and B are parallel to each other. Or 61, if A is any vector, the vector with 5 times. 5 times is given that 5 times means that 5 multiplied by that vector, the length of A. For example, A is given that the length of A is any vector and then if 5 times we can write 5 times of that one. So, an oppositive and direction of this vector, the given vector, in opposite direction means here minus 5. So, the given answer is here C is the correct answer. In this question, 62, if A and B are any two vectors, then A minus B cross product in A plus B. What is the result? If we are applying here the definition of cross product, so we are expanding A minus B cross A cross A vector plus B vector. How we calculate? If we are applying the Bermuda, first we if multiply with A cross plus B. Similarly, B is with the same vector minus B vector cross A cross plus B vector. Now using the properties here A cross A, expanding A cross A plus A cross B. Similarly here B cross A and minus into plus minus B cross B. So this is the definition A cross A and B cross B. So the result will be equal to 0. So this result is 0 and here this result is 0. Here is the remaining part is here A cross B, A cross B minus B cross A. Now here is this minus gives the opposite end direction. We change it this one A cross B plus, yeah, minus we can write definition we are applying A cross B. So minus into minus here we get plus A cross B plus A cross B. So if we write in the form of this one A cross B the coefficient, we can add this one to, so here the correct option is we are taking here C is the correct option according to this property. Vectors A, B, C, if A dot B plus C and B dot A minus C. So according to the definition, if we are applying here b dot a plus c, here is required, but here in opposite direction is changed, then what is the results in the given vector are satisfied, because and a, b and c is required, then c is required, and here the c vector are here, one is that one and that one. So this option is completely wrong. If we are applied here, c dot a plus b is required according to this property. So here correct option is C is the correct option according to the property. Is this? These are the properties. If we are applying here, A, B, and C are given. So here C dot A plus B. So that one is according to the properties. If we are applying, the correct answer is here is C. And question number 64, if A and B and C are three non-zero vector, they are non-zero vector means they are not equal to 0, then expression A dot B dot C. So this is not the definition. Scalar triple product, we are applying scalar triple product A dot B cross C. So this is the definition of scalar triple product. A volume of also is equal to the same, and dot product of any two vector A dot B. So this is the dot product. So here is the definition is not given, A dot B dot C. So that is called meaningless result, and this is completely wrong. They have no giving the information. So that result is completely wrong according to the definition, because we can also write this definition A, B, and C according to the vector form. This one is also right. So this is completely wrong, meaningless. The definition are not obeyed here. Now we are proceeding the next question. Question number 65. Decide whether P is given that and Q is also given that they are parallel, perpendicular, neither parallel nor perpendicular, and none of these. So according to we check one, this result is parallel or perpendicular according to the property of we apply P dot Q. We want to check that one. 6i plus 7j and dot Q. Q is given that minus 7 divided by 2i plus 3j. If we are multiply P dot Q, so 6 multiplied by minus 7 divided by 2 I dot I, and I dot j is equal to 0. Similarly, plus 7 multiplied by 3 j dot j. So I dot I and j dot a is equal to 1. Here the result is 1. Both are equal to 1. Here is 1 and here is 1. So this will be cancelled to 3. Here we get minus 21 plus plus 21. Both are cancelled. So it means that the given two vectors are perpendicular to each other because their dot product is equal to 0. Direction, three-dimensional vector I, j, and k, and here is j cross I. J cross I, J cross I in opposite direction means that it is equal to minus K. So and here is the correct answer is D is the correct answer. Similarly, I cross K is required. I cross K. I cross K, if we are applying here I cross K, it is also in the opposite direction. So that will be equal to minus J. Minus j. Here C is the correct answer according to the definition of cross product. If we are applying the moment of a force is given that I plus j plus k, and at a point here is what is any point is applied, and from the above its through at origin. and here is the point force is applied and it's any point on the origin. So it means that here given that if we take O as the origin, so 0, 0, 0 is the origin and P is any point, we can write in this form 1, 2, 3, and we take the position vector here OP, so we can write 1, 2, 3 minus 0, 0, 0. So the result will be equal to 1 minus 0, 1, and 2 minus 0, 2, and 3. So the position vector is R we get, and here force is also given that force is equal to I plus J plus K plus K. So if we are moment of a force is required. So moment we are applied R dot F. So R is equal to 1, 2, 3, and if we can write in this form and also in vector form 1, 1, and 1 dot 1 and 1 and 1. So if we are also in the vector form, we write 1 plus 2j plus 3k dot I plus j plus k. We write in this form. So I dot I we get 1 and 2 dot j is equal to plus 2 iota we get I plus 2 plus 1 2j and 3 plus 3k. Now if we check here, the answer is I plus 2j plus k. So the correct answer is here, G is the correct answer. If we are applying the property, this answer is correct. A vector A on B, on B, on B. So the projection of a vector A on B according to this definition, if we are A dot B, the magnitude, if we are applying here the projection of B on A. So B dot A, B A magnitude. So and here is given that the projection of A on B. So and here we check the answer. A on B is the correct answer is C is the correct answer. This option is correct according to the definition of projection of a vector on B. So the first option is correct. C option is here correct. A dot B, B magnitude. Thank you very much for watching. Please subscribe my channel.